During this lesson, we are going to talk about the area of irregular shapes. Students, you already know the area of a quadrilateral, which includes a parallelogram, trapezoid, square, and rectangle. We've also learned the area of a triangle. So we're going to take what we've already learned about those area shapes and apply it to irregular shapes. So here I have a shape that looks like a cross, and it has the different measurements on it. So what we're going to do to make this easier for us, because there is no area of a cross, there's no formula to memorize, we're going to break apart the cross into shapes where we are familiar with that formula. So I'm going to begin by breaking the shape. I'm going to begin by breaking the irregular shape into regular shapes that we're familiar with. So I'm going to make this into a rectangle, this into a rectangle, and now we have 3 rectangles. So we'll call this rectangle A, rectangle B, and rectangle C. So what we'll do with that irregular shape is find the area of each rectangle, and then we'll add those amounts together. So let's start with shape A. It's a rectangle, so we know that the area for rectangle is area equals base times height. Children, please make sure that you're writing out the formula. A lot of the times, the more you write it, the more it stays in your brain. So we'll simply do A equals, and the base is 3 inches. The height is 4 inches. So we know the area for shape A would be 12 inches squared. We've just done A, and it might help to put a check mark next to the shape as you solve for its area. It kind of helps you keep your work organized. The next shape we're going to talk about is shape B. And for shape B, we're going to use the same formula because it's a rectangle. We're going to plug in the measurements of the base, which is 2. And we're going to have to use the information given to us to figure out the height. So here we have a measurement of 5, and from here to here is 4, so that's 9, and then 9 plus another 5 is 14. So you have to use the measurements they give you if it's not given explicitly. In other words, use the numbers they give you to solve, because it doesn't necessarily say that this is 14 inches. And then the area for shape B would be 28 inches squared. So we're cool with B. The final shape we have to work on is shape C. Once again, I'm writing the same formula because all of our shapes are rectangles. Now, remember, we do know the formula for triangles, so if we had an irregular shape that was a triangle, we'd be able to solve that one as well. So I notice that shape A and shape C have the same measurements. I could assume that shape C would have an area of 12 inches squared. But children, I really want to make sure that you're getting used to writing the formula and solving, because sometimes we might make a careless mistake, or there might be a different measurement on that next shape. So, of course, you are keeping in mind that shape A is 12 inches squared, but let's do the work just to make sure. Area equals, our base is 3 inches, our height is 4 inches, and so our area for shape C would be 12 inches squared. Now, we're not quite done yet. We have to add each of the shape's areas together, and that will be the total area of our cross or irregular shape. So shape A is 12 inches squared, shape B is 28 inches squared, and then shape C is 12 inches squared. It's 12, here your 1. So our entire area for our irregular shape is 52 inches squared. Let's try some more examples together.